Assalamu alaikum, dear students. Welcome to your first class of relations and functions. This is actually the first chapter of your syllabus. Before going to the chapter, I would like to recall the basics from class 11th. I hope that you are well aware about the definition of sets. That's a well-defined collection of objects and operations on sets. You know, there are different operations on sets. Its union, its intersection, its complement, and all those operations we have gone through in class 11th. One operation was there that was Cartesian product. With the help of Cartesian product, we were able to develop a set that has elements as ordered pairs. And after that, we were able to find the subsets of that very giant set. And you know the definition of relation there and function, but I would like to recall once again. A relation is actually the subset of that Cartesian product, any subset of that Cartesian product. So after that, in class 11th, we are now going to describe the types of the relations. So we have different types of relations. Say, for example, first type of relation is, it's called empty relation. So empty relation simply means a relation that's having no element. Next one, that is universal relation, a relation that has all the elements that are in the Cartesian product. So we have set A. If we try to find the Cartesian product A cross A, then this whole set is called as universal relation. Let's note that these two relations are called as trivial relations. Okay, so trivial relations, whenever it comes into your mind, you should take it as empty relation and universal relation. So we have different examples here. You can see them one by one, and we have some more definitions here. So reflexive relation, symmetric relation, transitive relation. These types of relations are usually asked in questions in your text. So we should know about these relations, what are they and how are they identified. So the first here that we would like to define, that's a reflexive relation. Reflexive relation is that type of relation if we have A related to A in a relation for every A belonging to the given set. Symmetric relation. A relation is said to be symmetric if AA belongs, A1, A2 belongs to any relation, implies that A2, A1 also belongs to that relation, where these A1, A2 are actually the elements of the given set A. Transitive relation. Transitive relation actually means if we have A1, A2 as an element of relation R and A2, A3 as an element of relation R, if this implies that A1, A3, that means the first entry of this ordered pair, first ordered pair, and the second entry of this ordered pair, second ordered pair, if this is an element as an ordered pair in a relation, then we call that this relation is a transitive relation. Okay, so once again we have some exercises on this, and next is the definition, that is equivalence relation. A relation is said to be equivalence relation if it is reflexive, symmetric, and transitive. Sometimes a relation is such that it's at the same time reflexive, it is at the same time symmetric, and it is at the same time transitive. Such a relation is called as an equivalence relation. So we have different exercises on examples on this. They are solved in your text. So after that, we have here exercise. Say it's exercise number 1.1. To go to this exercise, it's very simple. Question is like this: determine the whether each of the following relations are reflexive, symmetric, transitive. So the first relation that's given here, we are first of all given a set R that's equal to 1, 2, 3, 4 up to it's 14, and the relation is defined like this: a collection of ordered pairs where 3x minus y is equal to 0. That means y is related to first element is related to first entry is related to second entry in a thrice relationship. So if we want to check whether this is an equivalence relation, whether this is reflexive, symmetric, or transitive, whatever it is. So for that, we go to the solution of this. So you see here, we have this given set. We have this relation given as, and we want to solve this. We actually try to find the elements in the relation. So in the relation, we will be having the elements like this. See, here it's actually 3x minus y. That means y is equal to 3 times x. So if x is equal to 1, y will be 3. If it is 2, it is 6. If x is 3, it's 9. If it is 4, it's 12. So we cannot go beyond 4, because if it is 5, it will be 15. But 15 is not an element of the given set A. So that's why we say that the given relation has only these elements. Now we will check whether this relation that we have found here is reflexive or not. You see that 1 is here, but 1 is not related to 1, so it's not reflexive. 1, 1, 2, 2, that means every element of this given set is not related to itself, so it's not reflexive relation. It is symmetric or not? Let's check. Here it's 1, 3. 1, 3 is present in the given relation, but 3, 1 is not there. So we see that it's not a symmetric relation. Similarly, we will check its transitivity. You see that it's 1, 3 that belongs to the given relation, and 3, 9. But 1, 9 does not belong to the given relation. So we say that this is not a transitive relation. Hence, R is neither reflexive, nor symmetric, nor transitive. Similarly, let's go to the next part of this question, that is a relation R in the set n of natural numbers defined as, it's y is defined as x plus 5, where x is less than 4. That means in the domain, we will have to go up to 4, not 4. We'll have to go up to 4. So these are actually the natural numbers. That means we have to take the value of x as 1, 2, and 3. So y will be calculated accordingly. Let's see. It's part number second, and it is here. You see here, we have to go in the x as 1, 2, 3, and for y, we have to add 5. So it's 1, it's 6, it's 2, and we add 5, it will be 7. If it is 3, we'll add 5, it will be 8. So it is seen that 1, 1 does not belong to R, so it's not reflexive. Is it symmetric? 1, 6 belongs to this, but 6, 1 does not belong to this relation. So we say it is not symmetric. So is this given relation a transitive? No, not at all, because you see here in this question, we have 1, 6 is here. Since no pair in R is such that, then x, if it is xy, it's yz, then xz cannot belong to R. R is not transitive, so we see that it's not a transitive relation. Next question is based on the divisibility. So y is divisible by x. So in this relation, if we want to find, and we have a given set here, 1, 2, 3, 4, up to 6. If we want to develop the relation, it's actually the divisibility. So the question is like this: y is divisible by x. So clearly, y is divisible by x. We can take y as x, because x is divisible by x, so it is reflexive. Is this symmetric? For example, let's take the element 2, 3 or 2, 4. 2, 4. Let's take 2, 4. 2, 4 belongs to this because 4 is divisible by 2. Does 4 2 belong to this? Say no, because 2 is not divisible by 4. So it's not symmetric. Is this transitive? Let's check. So we can see here it is, for example, xy belongs to R and yz belongs to R. That means y is divisible by x and z is divisible by y. So clearly z will be divisible by x. So this is transitive. So this is a relation that is reflexive and transitive but not symmetric. So on the same lines, we have different questions here in this exercise. I hope that you can do it. You try your best and ask me if there's any difficulty in solving these questions. I'll be more than happy to answer your queries. Uh, Thank you for joining the class. Thank you once again.